Hi guys, welcome back. Today we're pretty much just going to do some more optimization problems, more of the same. I'll introduce a bigger variety, but we're just going to do 3 problems. You may want to print out the 3 problems in advance so that you can write on them in your notes, but that's up to you. Here we go. Okay, read the problem very carefully and draw a picture. And I would like you right now, without my help, I want you to actually draw a legitimate picture and label it. And let's see what you do. Now, the reason I made a big deal of that, I hope you did it without waiting for me. I want to make sure that you label properly. It's a square base, but it's a box. So that's key. That's key. And how you draw it and how you label it, it's going to make all the difference in the world. Okay, now that's a lovely picture. It's pretty crappy. Who cares? That doesn't matter. What matters is how I label it right now. Okay, so you want to make sure that if they say it's a square base, you mark it XX. But they didn't say anything about the third dimension, but it's not necessarily a square, so this better be a Y. That's the key. 3 dimensions, 3 variables, but square base, okay? The next key, they tell you it has a volume of 32,000 cubic centimeters. Do not write volume equals 32,000. Don't do it. Waste of space. Don't do that. Instead, write specifically what is 32,000. Well, if it's volume that's 32,000, then use your picture over here. How would you find that volume? X times Y. So X squared Y. That's what's 32,000. That's the useful way to write the given information. Okay? Next, we're minimizing the amount of material used. Amount of material used. Well, that's actually the area of the material. You're really finding the surface area. Okay? So let's figure out what formula we're going to use. We're going to have to figure out that formula on our own, and let's give it a name. Minimizing the amount of material? I'll use an A for that. Okay? So amount of material. Make sure you've read carefully. This box does not have a top. So don't count this guy when you're looking to figure out the area of each surface. Okay, so the amount of material. Well, the bottom of this thing is a square, so the area of that would be X times X. The sides are all the same, X by Y, and there are 4 of them. So I have 4 sides, and each of them has an area of XY. They want us to minimize that, so we will be finding the derivative and setting it equal to 0, and make sure it goes from negative to positive. Okay? I'm going to clean this up so I have a little bit more space, but that's the main idea. Once I do this for you, the rest of it is actually usually pretty easy and no different than what we did yesterday, okay? 3 equations. You've got your given information, which you want to write it usefully. Then come up with a name and an equation for the thing they want you to optimize, and then don't forget to actually optimize by getting the derivative and setting it equal to 0. Okay? Now I'm going to rewrite this a little bit neater. I didn't give myself enough room, so I'm going to pause. Okay, so same as yesterday, we're going to want to get rid of one of the variables using the given information. So I think it's easier to plug in for Y since there's only one Y variable over here. So Y is equal to 32,000 over X squared. Rewrite this equation with one variable. Change the Y to 32,000 over X squared. Simplify completely and then do the derivative. I have an X squared here. One of my X's will cancel. One of these cancels with one of these, but I still have to multiply the 4 and the 32,000. So I have 128,000 over X. Okay, now do the derivative. Remember, you're going to rewrite. You're going to visualize that X in the numerator, or you can rewrite it in the numerator. Okay, and now we're going to do the derivative of it. So the derivative would be 2x minus 128,000 x to the negative 2. Okay, set it equal to 0. I'll move the fraction to the other side. Cross multiply or multiply both sides by x squared. Divide by 2. Cube root it. And you get 4,000? Is that 4,000? Or 40? Duh. Definitely going to be 40 because the cube root of 64 is 4, but the cube root of 1,000 is 10. Okay, so I have x is 40, but now I have to reread the question and make sure that I've answered everything they asked for. It says find the dimensions of the box. So the dimensions, going back to my picture, I have an x of 40, another x of 40, and what is y? To find y, I would plug in right here. So y is going to equal 32,000 over 40 times 40, which is 16 with 2 zeros. Okay, divide that. 2 of the zeros would go away. 32 divided by 16 is 2. I think I get 20, but I would double check my math. And then usually when you write it, when they ask for dimensions, I just write the dimensions would be 40 by 40 by 20. Okay, so main idea here, the hard part about this one is recognizing a picture. When they say to draw a box or a solid figure or whatever, make sure if it says a square that those dimensions are labeled with x's, but the other dimension is not an x, okay? Also pay attention to whether or not it has a top, okay? The given information was volume, but don't write V equals. Actually write how you get that volume, length times width times height, okay? Also, pay attention to what you're optimizing. Write a formula for that, and remember to get the derivative of that, not the other thing, because this could have been done either way. I can give you the amount of material and ask for the minimum or maximum volume. So you got to make sure this problem could have been reversed, okay? Make sure you're doing the derivative of the correct equation. All right, let's try another one. Okay, this one you might not quite understand what they're describing, but you'll have several in your homework like this too. Often it's like they're fencing in a pen, like fencing in an area for animals or something like that. So a 2-pen corral basically means you have a rectangular, you're going to have a rectangular fenced in region, okay? And they want to divide it into 2 parts, so something like that, okay? The outline of the corral forms 2 identical adjoining rectangles. Okay, it honestly doesn't matter if you drew the rectangles this way, you'd still get the same answer in the end, believe it or not, okay? So there's 120 feet of fencing. All right, let me clean up my picture already, start over. Okay, that's much better. So I usually, where you put your X's and Y's on this, you could do it more than one way, but I usually do the entire length. I call this entire length X, okay? And then up and down, I'll call that a Y. Now, it says the amount of fencing is 120. Well, if we're fencing in all of this region, how much fencing is that? Exactly what is 120? Well, I would have an X here and an X here, so that's 2X. But how many Y's would we have? There's a Y here, a Y here, and a Y here. So the amount of fencing would be 2X plus 3Y. Okay, so hopefully you understand where that came from. Now what do they want us to maximize? We're going to maximize the enclosed area, which is the outside rectangle. So we're maximizing the area of the whole thing, which would be X times Y. And then we're going to be doing its derivative, setting it equal to 0, make sure it changes positive and negative. I know I never actually do that, and I should. All right, so get rid of the fact that we have 2 variables. I guess I could either get X or Y by itself. I don't see that one of them is necessarily easier than the other. So I'm going to get Y by itself. I'm going to divide each thing by 3 this time. I think that's a little easier. And we get 40 minus 2/3 x. Okay, replace that in the area equation. 40 minus 2/3 x. Distribute. And there you go. Now minimize or maximize. Find the derivative. 40 minus 4/3 x. Set it equal to 0. Multiply by 3 and divide by 4. And x equals 120 over 4 or 30. Okay, so they want to know the dimensions. So I need to find y also. So I'll be plugging that in right here. If x is 30, I'm going to divide that 30 by 3, which would be 10 times 2 is 20. 40 minus 20 is 20. Double check my math. But if my math is right, then the dimensions of the outer pen would be 30 by 20. Okay, so what was different about that one? I'll double check the math in a second. But what was different about this one? You have like a fenced in area for animals. Okay, maybe you need to keep the horses separate. I don't know. I don't work on a farm or know anything about farms. But you have a rectangular area divided into 2 equal parts. Okay, I always label the outside x, and then each of these are y's. It is possible to do the problem where you call these guys x, but I think it makes the work a little harder. You would still get the same answer, though, as long as you interpret it correctly. Remember, your answer is never just what does x equal, because you're the one who's deciding what x actually stands for, okay? So the given information was the amount of fencing, and there were 2 x's and 3 y's, and they wanted us to maximize area of the outer pen, so x times y. Okay, that's going to be a pretty common type of question. I hope you did all right with that. Let's do one more. Okay, minimizing cost. Of course, that's a realistic thing. Yeah, we want to minimize cost. I want to maximize profit, and I want to minimize cost. All right, so I want you to read this to yourself, draw a picture, hit pause. I'm getting a little better at my pictures. Okay, so did you draw a box? Does it have a square base? Did you label it? If it has a square base, but you don't know about the other dimension, then it's 2 x's and a y. This one does keep the top. All right. So, did you write down your given information? We want the volume to be 8. So, what exactly is 8? X times y is 8. So, x squared y is our given information, and that's 8. We're minimizing the cost. So we're going to write an equation for cost, and then we're going to remember to do its derivative. Okay? So what is the cost based upon? Well, the cost is based upon the amount of materials used. And there's a hint in these words right here. The cost is per square foot. Well, that's telling you you're getting charged by the area of the parts. Okay? So, the bottom is $4. So the bottom is going to cost me $4 for every square foot. And the number of square feet on that bottom is the area of the bottom, x times x. So it's 4 times x squared. Okay? The sides are going to cost me $3. Okay? So it's $3 for the total area of the sides. Well, the area of the sides are xy, but there are 4 of them. So that's 4xy, and we'll have to multiply that out. And then the top costs me $2 per square foot, and the top is another x squared. Okay, so that's my cost equation. Now I'm going to just clean that up a little bit. I have a 4x squared and a 2x squared, which is 6x squared, and the 3 times 4 is 12xy. Once you understand this concept, the problem is not really going to be any different than the last one. So if you want to fast forward through the rest of this video, I understand. The new stuff is setting it up. Okay? Get rid of a variable. I'll get y by itself. Substitute that in over here. Simplify it. One of those x's will cancel. And my new cost equation would be 6x squared plus 12 times 8 is 96, and we have an x on the bottom, okay? You can move the x up and make it a -1, or you can do it in your head. All right, do the derivative. The derivative will be 12x minus 96x to the -2. Set it equal to 0. Move the 96 over x squared to the other side. See, we keep doing the same math over and over and over and over. Multiply by x squared on both sides, and you get 12x cubed equals 96. Divide by 12, and x cubed is 8. Cube root that, and x has to be 2. Now let's read the question. What dimensions will minimize the cost? So we want x and y. So plugging in the y right here, or plugging in the x right here to solve for y, y ends up being 8 over 4, which is 2. So the dimensions are 2 by 2 by 2, which means this actually ended up being a cube, but it didn't have to turn out that way. All right, hope you guys are doing well. On today's worksheet, I write at the top of it that you can skip a few problems. It really just comes down to whether or not those problems where you have two numbers that add to something and multiply to another. If you are already real comfortable with those problems, then feel free to skip them just to save time. That's up to you, your prerogative. Good luck, guys. Keep emailing me with your questions, and hey, have a great break. Be safe, have fun. Bye.